Warm good evening to one and all. I am Reshma, research scholar from Department of Civil Engineering, IIT Madras. So, this session is particularly for the NPTEL course Geotechnical Engineering I, or basically the soil mechanics. Here, we'll be having live discussion sessions on every Monday from 6 pm to 7 pm, where we'll be discussing the previous year assignment questions of the NPTEL course. Also, any doubts you have regarding the course can be cleared in these sessions. So I shall share my screen now. Hope my sharing is visible to you. I am putting it in the screen share mode. Sorry, slide share mode. Okay. Hope it is visible to everyone. So, soil mechanics or geotechnical engineering 1. So, what is basically soil mechanics? You all might have already learned solid mechanics, and some might have gone through the course fluid mechanics as well, which deals with the mechanics of solids and mechanics of fluids respectively. Likewise, the subject that deals with the mechanics of soil is the soil mechanics. Here, we study the physical properties of soil as well as the relevance of these properties as they affect the soil strength, stability, and drainage. So let's check on with some theoretical and numerical questions. Here's the first question. The materials having same elastic properties in all directions are called option A hard, option B brittle, option C homogeneous, option D isotropic. So, in order to answer this question, we must know what is meant by a hard material, what do you mean by a brittle material, what's a homogeneous material, and what's an isotropic material, right? Okay. So, what's a hard material? To remember easily, consider a cake which is soft, yes, and you can cut it with a knife, right? Okay. So, the material or substance which you can cut with a knife or make an impression or you can scratch are soft. Obviously, hard is the opposite of soft. So, hard materials are the one that you cannot scratch or cut. Second option is brittle. What is brittle? It is that material which fractures down, which breaks down. Now comes the homogeneous. What is homogeneous? Homogeneous means same in all directions at all points. If the properties are same in all directions at all points, it is homogeneous. Now the last one, isotropic. That is the material which has same property in all direction. Let it be elastic property, plastic property, whatever property, that particular property will be same in all the direction, then it is called isotropic. So the answer is option D, isotropic. So isotropic material is a material having identical values of a property in all directions. Hard, as I told, hard materials are those which cannot be easily compressed, cut, bent or scratched. Brittle material are those that fractures when subjected to stress. But of course, they have a tendency to deform before rupture. And last, the homogeneous material which has the same properties at every point. If you don't have any other doubts, we can move on to the next question. Second question is, the circle obtained from two-dimensional stress system is known as. Does anyone know the answer? You can put it in the chat box or you can unmute yourself and please respond. Yes, the answer is Mohr circle. Mohr circle is drawn from two-dimensional stress system and was developed by Mohr in 1870. Now the next question is, how is the Mohr circle representation there? That is, in the Mohr circle, where is the shear stress represented? Where is the direct stress represented? So the graphical method of Mohr circle represents shear stress on which axis is the next question. Yes, it is y-axis. Shear stress is represented on the y-axis and direct stress or the normal stress on x-axis. As you can see in the figure, y-axis we have the shear stress and x-axis the normal stress or direct stress. Now coming to the next question. Principal planes are planes having option A, no shear stress, option B, maximum shear stress, option C, minimum shear stress, option D, none of the above. Which is the right answer? Yes, option A, no shear stress. Principal planes are the planes where shear stress does not exist at all. That is, shear stress is zero. That means along the principal plane, only normal stress act or the direct stress act. And the principal plane with maximum normal stress, we call it major principal plane, and minimum normal stress, we call them minor principal plane. Coming to the fifth question, which of the following stresses can be determined using Mohr circle method? Yes, it's option C, principal stress. Now coming to the next question, what is Poisson's ratio? As we have learned this from mechanics of solid as well, it is the ratio of, yes, it is lateral strain to longitudinal strain. Now here I'll pause for a moment. If you have any doubts, please ask or else we'll continue. Alright, so if you don't have any other doubts, let's continue with the seventh question. Unit weight of water is option A 9.81 kilonewton per meter cube, option B 1 gram per centimeter cube, option C both options A and B are correct, option D none of the above. Yes, option A is right. Yes, option B is also right. And then, so the both options A and B are correct. That is, when we represent unit weight in kilonewton per meter cube, unit weight of water is 9.81 kilonewton per meter cube. And when it comes to gram per cc or gram per centimeter cube, it is 1 gram per centimeter cube. So the answer is option C. All right. Okay. The last question for the day. The property of a material by virtue of which a body returns to its original shape after removal of the load is called option A plasticity, option B malleability, option C ductility, and option D elasticity. Again, here we need to know what is plasticity, what is malleability, what is ductility, and what is elasticity. Yes, the answer is option D, elasticity. That is, the property of a material by virtue of which a body returns to its original shape after the removal of the load is called elasticity. You can take the best example as the rubber band. When we stretch it, it will come along with our hands, and once we release the stress or stretching, it will go back to its original position. So that property is termed as elasticity. If that object is not going to its original shape, then it is plasticity. So plasticity is the property of a solid substance that allows it to keep deformed shape even when the external load have been removed. Right. Now what is malleability? It is the property by virtue of which the material can be made into thin sheets. It can be made into thin sheets either by applying, hammering or rolling. What is ductility? It is the ability by virtue of which the material can be drawn into thin wires. So if it has the ability to be drawn into thin wires, it is ductile. Thin sheets, then it is malleable. And if it is not at all going back to its original shape, it is plastic. And if it regains the original shape, it is elastic. Okay, so for today we have only this many questions. So if you have any doubts, if any doubts are there, we can clear it off, or else for today we can conclude. and we'll meet in the next session. Thank you all.